Hello all. Today we will be doing one of the more interesting proofs in differential calculus. Um, we will be proving that the derivative of tan x is equal to secant squared x. So here we go. So to start off, we know that the derivative of tan x is equal to secant squared x. So we will be proving this to be true. So to start off, we know that tangent is just equal to sine over cosine. With that given, we can basically just take the derivative of sine x by cos x, which is just like taking the derivative of tan x. So in order to do so, we see that this resembles this format, which is the derivative of f of x divided by g of x. We have two different functions, the sine and cosine. So when we have two functions divided like this in a fraction and we're taking the derivative, we need to use the quotient rule. So the quotient rule basically tells us that we need to take the derivative of the top function, which is f prime of x, multiply it by the bottom. I'll write it in a separate way actually. So we just write down the bottom function, multiply that by the derivative of the top function, which is f prime of x, and then we subtract that from the top function multiplied by the derivative of the bottom function. And all of this is over the bottom function squared, so g of x squared. So this is the quotient rule, and we will just be following this rule. So I'm just gonna move this thing down a little bit so we have it in front of us. So this is the quotient rule right here. So we're just following this. I'm also going to um, write this down here so you guys don't get confused. d dx sine x cos x is equal to d dx tan x. Alright, so let's just start plugging in. So we know that g of x is the bottom function, which is just equal to cos x. And we also know that sine x is equal to f of x. So using this information, we just plug this all into this rule here. And if we do that, so g of x is cos x, so cos x times f prime of x. So the derivative of f of x, which is cosine of x, so cos x, minus, now the top function, which is just f of x, which is sine x, times the derivative of g of x. So the derivative of cos x is just negative sine x. And this is all over our g of x squared, and g of x is cos, so cosine squared. Now let's just clean this up a little bit and simplify. So cosine x times cosine x gives us cosine squared x minus sine x times negative sine x would give us a negative sine squared x. So this just turns into the positive, so cos squared x plus sine squared x. And then we just have our bottom function, which is cosine squared x in the bottom. So now, we do need to know a trig identity in order to solve this further. So we know that cosine squared x plus sine squared x can also be equal to 1. So the way we find that is that if we picture a triangle here, and then we call this, let's call the base square root of 3 over 2. We'll call the height 1/2. And we will solve for the hypotenuse here, which is just x. So this is just square root of 3 over 2 squared plus 1/2 squared is equal to x squared. Now this is just a Pythagorean theorem. This is just a squared plus b squared is equal to c squared. That's the formula we're using. Now the square root of 3 over 2 squared is just 3 over 4. And then the square of 1/2 is just 1 over 4, which is equal to x squared. So we know that 3/4 plus 1/4 is just 1. So 1 is equal to x squared. And the square root of both sides. So this would just be equal to 1. Alright, so since we're only concerned about the hypotenuse length here, which is x, we can disregard, this is actually plus or minus square root of 1, but since it's just the length of the hypotenuse, we can just call it the positive value. So the absolute value of square root of 1, which is just 1, is equal to x. So now that we've solved for our hypotenuse, let's plug that in for x. Now, given this, let's see what happens when we find our sine. So pretend this is 30 degrees right here. 30 degrees is also pi over 6 radians. So when we do the sine here, sine is equal to opposite over hypotenuse, so katoa, right? So the opposite value is 1/2, and the hypotenuse is just 1. So 1/2 divided by 1 is just 1/2. And then the cosine is equal to our adjacent over hypotenuse, which is, I'm trying to move this, give me a second. So our cosine is just equal to square root of 3 over 2 divided by 1, which is just 1. So now, if we do our sine squared and plus cosine squared, what does this equal? Let's see, we know that sine is 1/2, so 1/2 squared again. And then we have our cosine, which is square root of 3 over 2. So square root of 3 over 2. We square this, and we still get 1. This because this turns into 1/4, and like we did earlier over here, it's the same thing. We see that 1/4 plus this, which is 3/4, just gives us 1. So this is why we know that sine squared x plus cosine squared x is equal to 1. That's the proof for that. So now given this information, going back to the derivative of tangent of x, we can just simplify this top part here, which is cosine squared x plus sine squared x. Since we found that that's equal to 1, we can call this 1 over cosine squared of x. Now, I'm just going to move this to the bottom. So, also we know that secant is equal to 1 over cosine, right? It's just the reciprocal identity. So given this, if secant is equal to 1 over cosine, and so then 1 over cosine squared should also give you secant squared of x. And the way we know this is, you see how secant is equal to 1 over cosine? So 1 over cosine squared should give you secant squared. And the reason for that is just if you square this side and you square this side, you get secant squared here, which is equal to 1 over cosine squared, which is just this. So given that, we know that tangent, so the derivative of tangent x is equal to secant squared x. So that was just the proof of the derivative of tangent of x being equal to secant squared x. Thank you guys. Leave a comment below and let me know what you want to cover, what you want me to cover in the next video. Thank you.